In this video, we'll see how to plot bifurcation diagram for the logistic map. Bifurcation diagram is a widely used chaos detection technique to analyze the dynamic behavior of a chaotic map or system. It is plotted with R versus X, where R is a control parameter and X is the value of the chaotic map. The logistic map is a one-dimensional chaotic map. The equation is x is equal to Rx into 1 minus x. So we'll go straight into the coding of how to plot the bifurcation diagram. Logistic map is plotted here in this case for the range 2.5 to 4. Here R stores 10,000 values in the range 2.5 to 4. X will have the control parameter values and Y will have the X values of the logistic map. These two values will be finally plotted to get the bifurcation diagram. Next is the most important part of the program. Here we generate the X value for each value of R. For each value of R, X value is being randomly initialized. Then the first 100 values of X is being generated and ignored due to transient effect. Then again we generate next 100 values and the final value will be stored in Y. So this is the X value corresponding to the R value in this iteration. This is repeated 10,000 times. Finally, X versus Y is plotted. Let's see the output. So this is the bifurcation diagram. So we see we have plotted values 2.5 to 4 and the X value ranges between 0 to 1 for the logistic map. In case we need to have a more better look of the logistic map, let us see in the range 3.5 to 4 of the control parameter. So we have here a better lookup of the bifurcation diagram. If you want more points to be plotted, then we can change the number of control parameters. Here I've changed to 30,000. So here we see that it takes a little more time, but we have a better picture when we plot more points in the bifurcation diagram. So this program shows how to plot the bifurcation diagram for the logistic map. The same code can be used to plot for any one-dimensional chaotic map.